Okay, today we're going to work on more solving radical equations. Those are equations with a radical in it, square root, cube root, something like that. So I'm going to look at a couple of these right now. Look at the first one here. This was from the homework assignment for the weekend, number 17. The idea of this is we always want to get the square root by itself before we square both sides or do anything. So we have to basically eliminate this 8. So I'm going to subtract 8 from both sides of the equation. Okay, this side becomes 15 minus 8, which is 7. And these 8's cancel, and I have is square root of x over 8. Now to get rid of a square root sign, our rule was we just square it. It's just because square root squared, and I have to square this side as well. And when we do that, that basically the square root and the square cancel, and I just get x over 8. And this side's going to be 49. And what I've done is essentially turned a complicated problem with the square root into a basic problem with no square root. Now to get rid of this 8, what we do is we multiply this side times 8 and this side times 8. So 49 times 8 is 392, and that equals x. And there's our solution. We want to check to make sure that works. 15 equals 8 plus square root of 392 over 8. I just changed the x to what I think it's going to be. So that's 15 equals 8 plus the square root of 392 divided by 8 is 49. And that becomes 15 equals 8 plus 7. That's correct, so that's my solution. Second problem is similar. I have to first get rid of this 2, so I'm going to subtract 2 from this side and also subtract 2 from this side. These are going to cancel. And I have 10 equals the square root of 4 times p. Again, I want to get rid of this square root symbol, so I square this side, and I have to also square this side. So 100 equals 4p. Because the squared is basically eliminated here. Some people were writing 16 because 4 squared. That's not what happens. This square is taken care of by the square root. So essentially, some people like to say we cross it off like that. Technically, it's just not done that way, but that's it. Now for this one, we're going to get rid of this 4, like we did in 8th grade, by saying divide by 4. So that means 25 equals p. And then I check to see if that works. So that's going to be 12 equals 2 plus the square root of 4 times 25. So that becomes 12 equals 2 plus the square root of 100, which is 2 plus 10. 12 equals 2 plus 10, that checks. So this is my other solution to the second problem, or 18. The next problem on the homework is going to get a little bit trickier each time. It looks actually harder than it is. We have a square root isolated. Once we do that, we can start our square root, undoing the square root process. To do that, we square both sides. So I'm going to square this side, at the same time square this side. And what happens is it works out kind of nicely because the squareds cancel. I have b minus 1. And the squareds cancel here as well. 3b minus 7. That's a little, now we've turned it into a rather uncomplicated 9th grade problem. I want to get all the b's on the same side of the equation. Different ways of doing it. I like to put my b's on the left side. So if I do this, minus 3b, I get negative 2b minus 1 equals negative 7. I'm going to add 1 to both sides. Negative 2b equals negative 6. Divide by negative 2. And I get b equals positive 3. Some people would have done it differently. They would have looked at b minus 1 equals 3b minus 7. At this point, we really just, some people would have said, let's get the b's on this side, and I would have said minus b, and I have negative 1 equals 2b minus 7. Add 7 to both sides. 6 equals 2b. Divide by 2, and I still get 3 equals b. It's the same thing, so don't, if you didn't do it this way, that still works. As long as we end up with the answer, And when I check this answer back into the problem, I have the square root of 3 minus 1 equals the square root of 3 times 3 minus 7. Square root of 2 equals square root of 9 minus 7, which is the square root of 2. Since they're equal to each other, that checks. So 3 is my answer. Okay, this side over here, same idea. We're going to square both sides. And that gives me 2n minus 1 equals 3n minus 2. However we want to do this, I'm going to subtract 3n from both sides. And I have negative n minus 1 equals negative 2. Add 1 to both sides. I copied it down wrong, sorry. 2n plus 1 here, so this would have been plus, which means this part here, I apologize for that, minus 1, that gives negative n equals negative 3, n equals positive 3. And I want to check to see if that works, so to do that, I'm going to plug these back in. Square root of 2 times 3 plus 1 equals square root of 3 times 3 minus 2. So the left side of the equation becomes square root of 6 plus 1, and the right side is the square root of 9 minus 2. 6 plus 1 is 7, square root of 7 equals square root of 7, that checks also. So 3 is my solution. Now we're going to start to get a little more complicated. This is where it gets difficult a little bit because we have variables on inside and outside of the radical symbol. But our rules are going to be the same. We're just going to turn the new problems into old problems. It's just that the old problems won't be as easy as the ones we just did. So I'm going to have to square this side and I'm going to square this side. So the left side becomes a squared. The right side becomes 110 minus a. And this, because it is squared, is what we call a quadratic equation. So to solve a quadratic equation, we want to set it equal to 0. So I'm going to go through a couple steps here. First, I'm going to add a to both sides. And I have a squared plus a. I can't combine that. It's not a to the third because we're not multiplying, we're adding. And that equals 110. And now I want to get rid of the 110 because I need the right side to be 0, or one of the sides to be 0. So I'm going to, at this point, subtract 110. These cancel, and I have a squared plus a minus 110 equals 0. And my next step then would be to do this, because I want to factor this trinomial here. To do that, I know the first two terms are going to be a times a. Then the last two terms have to multiply to 110 and subtract to 1. And that's going to be 11 and 10. And the bigger number always gets this sign. And since it's minus or one of each, one's a minus, one's a plus, equals 0. And now to solve this, I could say a plus 11 equals 0, in which case a equals 11, negative 11. Subtract 11 from both sides. I'll leave that to you to figure out. A minus 10 equals 0. A equals positive 10. So I have two possible solutions, a negative 11 and positive 10. Let's check negative 11 first. So that's going to be negative 11 equals the square root of 110 minus negative 11. So negative 11 equals the square root. 110 minus a negative is plus a positive, so that's going to be 121. So negative 11 equals 11, and that's not true. This is not true, so that means negative 11 is not a solution. It's an extraneous solution, meaning it's a solution to a modified equation, but not the original. Now I'm going to check 10. So I have 10. We're going to check for 10. 10 equals Square root of 110 minus 10. 10 equals the square root of 100. 10 equals 10. That's correct. So this is the only solution we have to that problem. Okay. The next one is similar. We're going to square both sides. The square root of the square just comes out. So negative 9 plus 10m equals m squared. And again, we have a quadratic equation. So the quadratic means I want to set it equal to 0. So I'm going to subtract 10m from both sides. And I get negative 9 equals, these are going to cancel here, equals m squared minus 10m. And now I want to get rid of the negative 9. So I decide I'm going to add 9. It doesn't combine because we have m squared, m, and a constant. So that's just going to be 0 equals m squared minus 10m plus 9. To solve this one, I'm going to factor 0. What am I thinking? Okay. I have m and m to give me m squared. Multiply to 9 and add to 1. That's 9 and 1. 9 times 1 is 9. 9 plus 9 is 10. That works perfectly. They're going to be the same sign because of this plus. To get a plus at the last thing, these two numbers multiplied together have to give me positive 9, which means it's either going to be positive times a positive or negative times a negative. In this case, this tells me this being minus is going to be a negative times a negative. So now I have m minus 9 equals 0, so m equals 9. Or m minus 1 equals 0, so m equals 1. So I have two possible solutions. I'm going to check to see if they work back in the equation. Okay, I'm going to erase this one here because we've already used that area. Let's get a bigger one. So we'll do the check now for, we'll do check for 9. So I'm going to say square root of negative 9 plus 10, whoops, plus 10 times 9. Come on. Sorry about this. There we go. 10 times 9 equals 9. Basically, I replace this m and this m with 9. So that becomes then the square root of negative 9 plus 90 equals 9. That's the square root of 81 equals 9. 9 equals 9. That checks. So this is a solution. Now when I put the second one in, I get the square root of negative 9 plus 10 times 1 equals 1. So that becomes the square root of negative 9 plus 10 equals 1. Square root of 1 equals 1. That works as well. So in this case, we have two solutions. Sometimes we have one solution, such as over here. Sometimes two solutions. Okay, as I said, sometimes two answers, sometimes one, sometimes none. We got a lot of work to do, so I know we've been into this video quite a ways. If you want to pause it and come back to it, that might work. But I do want to finish these last couple problems because you're responsible for all these on the quiz this week, so it might be a good idea to watch them. This is where it gets really complicated here because, well, similar. What we're going to do is square both sides. So when I square this side, I have to also square this side. Now, squaring this left side, the right side is pretty simple to see. That's just going to be 6b minus 38. But when I square the second side, I'm not just going to be b squared minus 25. I'm squaring the entire side as a whole. So remember, when we square things in parentheses, a whole thing like that, we end up writing it b minus 5 times b minus 5. So at that point, we have to do our old FOIL trick that we did before. So that's going to be b times b, that's b squared. B times negative 5 is minus 5b. Negative 5 times b is minus another 5b. And negative 5 times negative 5 is plus 25. So this entire side over here, this side of the equation, becomes b squared minus 10b plus 25, because 5b and negative 5b and negative 5b is negative 10b. So now I have a quadratic equation with b's all over the place. Let's set quadratics. We always want to set one side equal to 0. So I'm going to choose this side to be 0 because I have a nice positive b squared there. That's perfect. So I'm going to subtract 6b from both sides. And that gives me b squared minus 16b plus 25 equals 0. Excuse me, it doesn't equal 0 yet. It equals negative 38. The next step is to get rid of the negative 38, so I'm going to add 38 to both sides. These will cancel, and I'm going to have b squared minus 16b plus, what is that going to be, 63 equals 0. And now I'm going to have to factor this right here, so I'm going to factor it to be b times b, that gives me b squared. I'm looking for numbers that multiply to 63 and add to 16. That's going to be 9 and 7. This tells me they're the same sign, and they're both the same sign, and the sign is going to be that. So I have b minus 9 times b minus 7 equals 0. So this equation up here has been transformed into this one, which is quite simple. b minus 9 equals 0, b equals 9. b minus 7 equals 0, b equals 7. So I have two solutions here that I need to check to see if they actually work. So when I put the first one in, first I'm going to put 9 in there. So I'm going to say, I'm going to check 9. So that's going to be 9 minus 5 equals square root of 6 times 9 minus 38. All I've done is taken this equation right here, this original equation here, without the square roots, let's get rid of those, without the squares, and I changed the b to a 9 and this b to a 9 also to see if 9 works. So that's going to be 4 equals the square root of 54 minus 38. So 4 equals the square root of 16. That checks. 9 is a solution. Now I'm going to check 7. That's going to be, just replace the b's with 7. 7 minus 5 equals the square root of 6 times 7 minus 38. 7 minus 5 is 2 equals the square root of 42 minus 38. 2 equals the square root of 4, and that's correct also. So there are two solutions to this problem. Okay, now for this next problem, 24, I'm gonna erase this checking part right here so we can redo the problem, do this problem, if I have room for the second problem. For this one, we're going to do similar what we did before. We first have to isolate the square root symbol. So I'm going to have to add k to both sides. This side's going to cancel. That gives me square root of 26 minus k equals, I can do negative 6 plus k, or just k minus 6 would probably be easiest. At this point, I have the isolated radical symbol. I need to square both sides. So I'm going to square this side. Remember, we're squaring the whole thing. So 26 minus k equals, now I have to figure out what k minus 6 times k minus 6 is. K minus 6 squared is k minus 6 times k minus 6, which is k squared minus 6k minus another 6k, that's a k, plus 36. So this side of the equation now is going to be k squared minus 12k plus 36. So now I go through all the steps that we did before. We've got to get this side over here to be 0. I'm going to add k to both sides. That would add here. So I got 26 equals k squared minus 11k plus 36. Now I'm going to get rid of this 26, so what I'm going to do is subtract 26 from both sides. So when I subtract 26, I get 0 equals k squared minus 11k plus 10. And factoring this now, k and k, and I multiply to 10 and add to 11. That's 10 and 1. And they're both negatives. Equals 0. So either k minus 10 equals 0, in which case k equals 10, oops, that's a k, equals 10, or k minus 1 equals 0, in which case k equals 1. And now I'm going to check both of those. I'm going to erase this other side over here because we don't need this anymore. We already have that. Okay, so let's do our check now. We're going to do a first, I'm going to check 10, and I'll put that square root of 26 minus 10. Not equal, so hold on a second. Minus 10. Let me put the 10s in different colors. Probably would look better if I did this. This is a 10. And then I'm going to have 10 here. Equals negative 6. So in the check for this, this becomes the square root of 16 minus 10 equals negative 6. So square root of 16 is 4. 4 minus 10 equals negative 6. That is correct. So 10 is one of our solutions. Now we're going to check to see if 1 works. So that's going to be, we're doing this one over here. So that's going to be square root of 26 minus 1 minus another 1 equals negative 6. So that becomes the square root of 25 minus 1 equals negative 6. That's 5 minus 1 equals negative 6, which is not true. So that's 1 is not a solution. So we only have one solution, and that's 10. All right, the last two problems we're going to do require a lot of difficult work here because we have 2 square roots in the problem. So it's going to be a little different with this negative 1. We're going to go through the steps again, square both sides. Now remember, when we square this side, it's going to be a little complicated because we're going to square it like this. We square the whole thing. So the right side is easy to find. That's going to be 6x minus 2. The left side is where it gets a little confusing because I have to FOIL that. So that's going to be negative 1 minus the square root of 4x minus 3 times negative 1 minus the square root of 4x minus 3. Which looks complicated, but we do what we know how to do. We're first going to multiply the first two things together. Negative 1 times negative 1, that's 1. Negative 1 times negative 4 square root of 3 is plus square root of 4x minus 3. And now we're going to do these two here. That's going to be plus another square root of 4x minus 3. And then the last one are these two together, square root of 4x minus 3 times square root of 4x minus 3 plus 4x minus 3. So this entire thing here goes on the left side of the equation. I can combine a few things together. These two terms here and here combine to be negative 2. These guys will combine to be plus 2 square root of 4x minus 3. And then I have plus 4x, like that, equals 6x minus 2. Now, when I look at this, I still have another square root, so I have to go through the whole steps again to get rid of this square root, which means I have to isolate that square root. So it's a long process, but it's just more work. It's not harder, it's just more work to do. So what we're going to do here is add 2 to both sides, and nicely that cancels out. So I have 2 square root of 4x minus 3 plus 4x equals 6x. Get rid of the 4x, subtract 4x from both sides. So I have 2 square root of 4x minus 3 equals 2x. Next thing I would do is divide by 2. These are going to cancel, and I have square root of 4x minus 3 equals x. And now it's become an easier problem. Still not super easy, but easier. I square both sides here, and that's going to give me 4x minus 3 equals x squared, which is another quadratic, and I have to solve that. So I'm going to add subtract 4x from both sides. These are going to cancel. Negative 3 equals x squared minus 4x. And I'm going to add 3 to both sides. I'm going to do this will be up here. 0 equals x squared minus 4x plus 3, which factors to be x minus 3, x minus 1. So my two solutions, this equals 0, of course. So that means x minus 3 equals 0, so x equals 3. X minus 1 equals 0, x equals 1. Now before we get all excited and say we're done with the problem, we have to check these guys to see if they work. So let's go back and check back here. I'm going to erase some things here. I'm going to erase all this because we already used that. Okay, let's see our checking. We're first going to check 3. When I put 3 into the equation, I have negative 1 minus 4, square root of 4 times 3 minus 3, that's also the square root, equals square root of 6 times 3 minus 2. And that becomes negative 1 minus the square root of 12 minus 3 is 9. This is 12 minus 3 is 9. Equals the square root of 18. 6 times 3 is 18. Minus 2 is 16. So I have negative 1 minus 3 equals 4. Negative 4 equals 4. It does not. So 3 is not a solution. And then I go back and do the same procedure. I'm going to erase this part here. So now what we're going to do is do the same thing, only instead of changing the x to 3's, we're going to change the x's to 1. So by doing that, this becomes a 1 here, and this becomes a 1 here. So that becomes, I should do a different color, a 1 and a 1 like that. That's what the x was. So now this becomes negative 1 minus 4 square root of 4 minus 3 is 1, equals the square root of 6 minus 2, which is 4. So this becomes negative 1 minus 1 equals 2. Negative 2 equals 2. It does not as well. So in this case, there are no solutions. Okay. And the final problem, which I'll try to do a little quicker, hopefully we'll get out of here. Well, at least I'll have it here. Let me rewrite that. I'm going to rewrite that over here so we have some room to write. That's going to be square root of 9 minus 9n equals 3 plus square root of 10n, like that. So again, we're going to square both sides of the equation. Remember, we square the whole thing here. So the left side is going to be 9 minus 9n. The right side, we have to do FOIL. 3 plus square root of 10n times 3 plus the square root of 10n, and just do FOIL. 3 times 3 is 9, plus 3 square root of 10n, plus another 3 square root of 10n, and then plus 10n. So that's going to be, this is going to be 9 by itself, plus 2 square root of 10n, plus 10n. And again, we have to have another radical, and we have to isolate this radical. So I'm going to do a couple things. I'm going to subtract 9 from both sides. That helps a little bit. And I'm going to subtract 10n from both sides. So I have negative 19n equals 2 times the square root of 10n. Okay, I'm going to divide by 2. Divide both sides of the equation by 2. Negative 19 over 2n equals the square root of 10n. Now, when I square both sides here, what happens is I get the left side becomes 361 over 4n squared equals 10n. Now to solve this one, it's a quadratic. We're going to set it equal to 0, so I have 361 over 4n squared minus 10n equals 0. So factor out an n. So I have, oh my gosh, this is going to be a mess. N parentheses, 361 over 4, n minus 10 equals 0. So either n equals 0, which is one possibility, or 361, let me pull this down a bit. 361 over 4 minus 10 equals 0, which means 361 over 4 equals 10. Excuse me, n here. So that would mean n is equal to, multiply by 4. Let's go 361n equals 10 times 4, which is 40. So n equals 40 over 361. So that's the other number I got to try in there. That doesn't look like it's going to work. In this problem, I'm going to stop right now because we've gone on 30 minutes. So this value does not work in the equation. It gives us something that isn't going to be true. So there's only one solution, and that's going to be 0.